Welcome back to OCR MEI past paper walkthrough. Today we're doing June 2014 Core 3. And so basically let's get started on doing section A. Right, question 1, evaluate the integral. So let's start with the original so this integral can be split into two. So one integral is just integrating 1 dx, the other one is integrating sine 3x dx, and we know that integrating 1 just gives you x within the limit. There's a 0 in the bottom here, and integrating sine gives you a minus cos. However, we need to do a chain rule, so it's actually 1/3 negative. Oops, that's no longer an integral, it's the limit. And now I know that the 1/6 pi is 1/6 pi in times 3 is half pi. Half pi is a special angle. And so we know that half of cosine of half a pi is just 0, so this whole term goes away. Well, the first part of this whole term actually, and 0 remains, so we have a take away cos 0, that is a minus a third, negative minus 1/3 gives you a plus a third, and that would be a negative eventually because of this other negative in the middle. And so we have 1/6 of pi, take 0 from the lower limit, take 1/3, so it's just 1/6 pi, take a third as your solution. Now for question 2, find the exact gradient. So y is natural log of 1 take cos 2x, and I know that the natural log of 1 take cosine 2x can be differentiated into 1 over 1 take cosine 2x, and because this is applying the chain rule for u equals to 1 take cos 2x, I have to change this to du on dx is sine 2 sine 2x, and so I multiply by 2 sine 2x, and now we must use again a special angle to do our bidding. We know that the x coordinate is 1/6 of pi, and we know that 2x is 1/3 of pi, and in terms of normal degree angle, that would give me 60 degrees. 60 degree in terms of special angle, we have 60 sine cosine, this is a half, this is √3 on 2, and for special angles, if you haven't checked it out yet, do have a look at the special angle video that I have, and that basically tells you how to remember all the special angle with a rather easy to remember method. But that set aside, let's keep doing this question. So sine of 2x gives me root 3 on 2, and we have a 2 prefix, which means that we just have a root 3 on top, divided by 1 take cosine of 2x is a half, which gives me root 3 divided by a half, which is just 2 root of 3. And that is the solution to the second question. Now for the third question, it is a mod question. 3 take 2x modulus is equal to 4 mod of modulus x. And there are two ways to do this. There is a sign change method and there is a square method. Let's do the square method. So we have 9 take 12x plus 4x squared is equal to 16x squared. So basically I've just squared everything on both sides. And now we can rearrange this to a 0 equals to 12x squared plus 12x minus 9. And this can be simplified, and we can first factorize it into 3 times 4x squared plus 4x take 3, and the ones who are good at factorizing, go for it. The ones who aren't, let's use the quadratic formula, which gives me that x is minus b plus or minus square root of b squared minus 4ac, and that gives me 4 times 4 is 16 times minus 3 is minus 48, and all of them divide by 2a, and I know that a is 4, so that is just 8, and that would give me minus a half plus or minus, so 16 minus minus 48 is 16 plus 48 gives me 64, and 64 square root is just 8, and 8 divided by 8 is just 1, and so now I have this minus a half plus or minus 1, which means that the solution is either a half or 3 halves. Well, minus 3 halves. And with this set, we can use the second method, which is the sign change method. It would give you exactly the same solution, but it's good to know how to do either of them. So let's keep the values on the left. 3 take 2x is equal to a positive solution for x, and we can rearrange to get 6x is 3, and therefore x is a half, as stated before. And now if we say that the right hand side is now negative instead, so 3 take 2x is equal to negative 4x, we can rearrange again to get minus 2x is 3, and therefore x has to be minus 3 halves, which again correspond to the original solution. So you can use either of the methods. They give you the same marks. It's basically just do whichever that you find the most intuitive or simple. Now question 4 is a bit more, it's more tricky than it looks. So we have the curve that looks sort of like that. And this ends on 2 pi, and this end starts at 0. We have point at 3, point at 1. So this whole setup is basically trying to get you to do a function transformation. So function of x is a function related to cosine, so a plus cosine of bx. And here I know that we can first look at the cosine formula and cosine function. I know that cosine basically work like that, and basically we need to do a transformation on the curve. So the given curve is a cutoff from pi, and basically we have stretched out the cosine equation. So in order to stretch this out horizontally, b has to be a half, because stretching is division and compressing is multiply. So we have stretched out the horizontal axis to get b is a half. And alternatively, you can say that cosine of pi is equal to cosine of b 2 pi, and if you do the algebra, you get that b is a half. Exactly the same kind of method or derivation. And for a is just the upward shift value for positive, downward shift for negative. And we know that the bottom of the curve is +1, top of the curve is +3, which means that a has to be 2. And so we have b and a, which is what the first part is asking. And now we need to find the inverse function in terms of x, and that would be rather simple if you just swap fx to x and swap x to f minus 1x, then we can rearrange. So let's give it a go. X is equal to a plus cosine of b f minus 1x, and we can do it x take a cosine of b f minus 1x. I know that I can do an arc cos. X take a is just b inverse of fx, and therefore the inverse of fx is just 1 on b arc cos of x take a. And this whole thing I can use number to show that it's actually 2 cos x take 2. And this is the inverse function, and with this inverse function we can state its domain and range. To be fair, because it's an inverse function, you can just read it off the graph of the original. So an inverse function is a reflection along the y equals to x line, which means that the domain becomes the range becomes the domain. So for the original, domain is equal, well, the domain is, let's see, it's between 2 pi and 0, whereas the range is between 1 and 3. But because now we are talking in terms of inverse, we know that these two swap, and so the range and domain is now flipped. Oops. This is now the range and this is now the domain, so domain and range is just 1 to 3 and 0 to 2 pi, so that's quite straightforward. So question 5 is a domain range question. So not domain range, question 5 is a rate of change question. From the question we know that the relation of volume to radius is 4/3 pi r cubed, which is a volume of a sphere, and we know that the inflation rate dv by dt is 10 centimeter cubed per second, and we know that it is a dv by dt instead of dr by dt because the units are centimeters cubed, which is a volume per second unit. Now we want to find the rate of increase of r, which is dr by dt, and we know that dr by dt is actually just dv by dr. Actually no, I should write dv by dr times dr by dt is just dv by dt, and we already have two elements. Well, we could get two elements of this. We know that dv by dr has to be 4 pi r squared. It's just differentiate this original expression, and now we have two elements of these this big equation that we have here. So we know that dr by dt is actually just dv by dt, which is 10 divided by 4 pi r squared, and I know r is 8 from the question, and so dr by dt is literally just 10 divided by 4 pi times 64, which if you plug into the calculator should give you 0.0124 centimeters per second. And this is the solution, and make sure you have the right unit, because we started off centimeters cubed as a volume, we have centimeters per second as our rate. Now question 6 is a interest or rate change equation kind of thing. It's standard. Part 1, fairly straightforward. Basically find the value after a year, so we know that phi is just 20,000 e to the minus 0.2, and I know t is 1, so we don't need to care. If you just put that into the calculator, you get phi is 16,374.6, and I know that the change in value delta phi is just phi take phi naught, where phi naught is the initial value 20,000, which would give me a loss of negative 3,625 5.4, and rounding to the nearest 100 gives me minus 3,600 pounds. And for part 2, we have a different car, but we need to find the value for K, which is given to us conveniently, so we can just cruise. So we know that the initial value of the car is 15,000, and by the end of the whole year, the car has lost just 2,000, which means that I now have 13,000 as my new value. If you do a division by 15,000, we get 13 on 15 is e to minus k. T is 1 year, so that doesn't matter. Now we can just do a natural log on both sides to get 13 on 15 is minus k, and that means that k has to be minus log of 13 on 15, and that in the calculator would give you that equal to 0.143, which is as expected. Now we want to find how long does both of the cars have the exact same value, and for that we just need to equate the two equations. So we have a 20,000 e to minus 0.2 t is equal to 15,000 e to the k minus kt, and I can just divide both sides by 20,000, or 15,000 actually works better here, to get 20 on 15, which is 4 on 3, is just e to the, if we multiply both sides by e to plus 0.2 t, we get e to 0.2 t take kt, and we can natural log both sides to get 0.2 take k t is natural log of 4 on 3, and basically I just factorize the exponent term on the left here, and we know that t is just natural log of 4/3 divided by 0.2 take k. If you use the k value given, and you just run these numbers through the calculator, you should get something along the lines of 5.05, which is just about 5 years later on they will have the same value. And now for the last question, which is a proof or disproof scenario. So part 1, if m and n are consecutive odd numbers, at least one of them are prime. So this one we can disprove by contradiction, because for large numbers this will clearly not work. One of the classic is 33 and 35, and 33 is clearly an 11 times 3, whereas the 35 is a classy 7 times 5, and that means that both of them are not prime, but they're consecutive, so therefore disproven by contradiction. Now we have part 2. Part 2 is more interesting to deal with. There are 2 ways to do it. One way is more straightforward, but requires previous experiences. One is you can just work it out, but it's a bit more convoluted. I'll start with the the one that requires experience. So I know that for all even numbers, they are a multiple of 2. And so I can hypothesize that m is actually 2y. And now consecutive even numbers means every 4 numbers in the number line. And so n is actually 4x. And therefore, m times n is actually 2y times 2x, or 4x actually, which gives me 8xy, which is divisible by 8. But this requires you to initially think that basically you have to know that every consecutive even number, there will be one of the value being a multiple of 2 and one value being a multiple of 4. It's just how number on the number line works. But if you don't want to use this method, or if you can't understand how this works, there's another way. The other way is a bit more tricky, but it's still doable. So let's state that m is also 2x for this situation. X can be any value, any real natural numbers. And we know that n is 2x plus 2, or we can also say that it is 2 lots of x plus 1. That would be the definition of consecutive numbers anyway, well, consecutive even numbers. And so mn is 4 lots of x times x plus 1, and I know that x times x plus 1 is x squared plus x. Now, from this, we would initially say, so it is divisible by 4, not divisible by 8, so disproven. However, the twist is x squared plus x is always even. This can be shown because 4 odd x squared plus x is odd plus odd, well, odd squared plus odd, which is odd times odd gives you odd, add another odd gives you even. And for even x, and it would just be even squared plus even, it's clearly even. And therefore, both of them can be written as an even number. So x squared plus x has to be 2 lots of, let's say, j, because m's taken. So x plus x is 2j, and therefore mn has to be equal to 8j, and that therefore is divisible by 8. And so this is how you can do this question, and it's this also concludes the first section, section A of the June 2014 paper. I hope you've learned something here. If you have any question, do let me know in the comments below, and I will see you shortly after I've done the session B part of this paper.